Hello, everyone. Welcome to the Masons online classroom. Today, I'll share with you the first part of the commonly used masonry materials. This session will cover two main categories, which are 1. Masonry bricks. 2. Wall blocks. First, let's understand the definition and classification of masonry bricks. Masonry bricks refer to bricks used in the construction of load-bearing and non-load-bearing walls, primarily made from clay, industrial waste, or other local resources through various manufacturing processes. The classification of masonry bricks can be based on raw materials, including clay bricks, shell bricks, coal gang bricks, and coal fly ash bricks. Based on production processes, they can be categorized as sintered bricks and non-sintered bricks. According to core ratio, they can be divided into solid bricks, porous bricks, and hollow bricks. Solid bricks have no holes or a core ratio less than 15%, porous bricks have a core ratio greater than or equal to 15%, and hollow bricks have a core ratio above 35%. One of the most used materials for masonry bricks is sintered common brick. Sintered common brick is made from main ingredients such as clay, shale, coal fly ash, and coal gang through the firing process. It is often named based on its primary ingredient, such as sintered clay brick. The main technical properties of sintered common bricks include dimensional deviations, appearance quality, efflorescence, and lime bursting, and these bricks are classified into first class, second class, and qualified products. The primary technical properties of sintered common bricks include 1. Appearance quality and dimensional deviation. Sintered common bricks have a rectangular shape with dimensions of 240 mm in length, 115 mm in width, and 53 mm in thickness. The face measuring 240 mm times 115 mm is referred to as the bed face. The face measuring 240 mm times 53 mm is called the stretcher face, and the face measuring 115 mm times 53 mm is known as the header face. 2. The strength grades of sintered common bricks. It has a total of 5 strength grades, which are Mu30, Mu25, Mu20, Mu15, and Mu10. The factors influencing the strength of sintered bricks include the quality of raw materials and the burning process. During the burning process, the bricks can be classified into well-burnt bricks, underburnt bricks, and overburnt bricks. It is not allowed for underburnt bricks and overburnt bricks to be present in sintered brick products. Other technical properties of sintered common bricks include resistance to weathering, efflorescence, and lime burst, all of which significantly impact brick quality and can reduce masonry strength. The second most used material in wall bricks is sintered porous brick. Sintered porous bricks typically have internal diameters not exceeding 22 mm, a core ratio of not less than 15%, and small-sized holes in greater quantity. Porous bricks come in two specifications: 190 mm times 190 mm times 90 mm, M-type, and 240 mm times 115 mm times 90 mm, P-type. These are suitable for bearing walls in buildings up to 6 floors. The third most commonly used material in wall bricks is sintered hollow brick, characterized by a core ratio of not less than 35% and larger holes in fewer numbers. With a rectangular hexahedral shape, holes have rectangular or other hole shapes parallel to the bed face and stretcher face. They are mainly used in non-loading bearing walls. Compared to solid bricks, sintered porous bricks and sintered hollow bricks offer advantages such as saving raw materials, reducing fuel consumption, and lowering costs. They also improve construction efficiency and reduce the weight of buildings while enhancing thermal and acoustic insulation. Sintered porous bricks, with higher strength and superior thermal insulation performance compared to ordinary bricks, are generally used for load-bearing walls in buildings up to 6 floors, while sintered hollow bricks are mainly used for non-load-bearing filler walls and partition walls. It is not permissible to use porous bricks and hollow bricks for masonry below ground level or the indoor damp course. Moving on to the second part, let's learn about wall blocks. The advantages of wall blocks are: 1. They make efficient use of local resources and industrial waste, saving clay resources and improving the environment. 2. The production process is simple, and the raw materials are widely available, making production and usage convenient and flexible. Construction efficiency is improved. 3. They can improve wall functions and reduce the weight of the structure. The differences between wall blocks and wall bricks in appearance include: 1. Larger size, where the main specifications of block series have one or more dimensions, length, width, or height, greater than 365 mm, 240 mm, or 115 mm. 2. Blocks are generally rectangular hexahedra but can also have various irregular shapes. The types of wall blocks: they are categorized based on size into large, medium, and small blocks, based on usage into bearing and non-bearing blocks, and based on materials into silicate blocks, lightweight aggregate concrete blocks, and ordinary concrete blocks. That concludes our lesson for today. Thank you all for watching.